So that's really what we're going to focus on. Is we're going to focus on disaster planning, AWS backup, and these recovery strategies. That's all part of this like module 13. Okay. All right, so let's talk about disaster planning first. So, Werner Vogels is quoted as saying everything fails all the time. I don't know, I don't know if it all fails all at once, all at the same time, all the time. But yes, pieces do fail, right? How do we mitigate risk? That's a solid statement. How do we mitigate risk? Now, I can't tell you how many disaster recovery game hackathon things I participated in, and they have just failed. Mainly because there's no plan, they either don't have enough resources, or they never tested whatever. Which is why I say that restores are important, backups are meaningless. Just because you have backups means nothing. When's the last time you restored those backups and went through the process of restoration and tested the data that came out of that restoration and tested the backup itself? So yeah, so many. I've been in IT since 1996, and so many wasted man hours because of these three reasons, right? Now, in terms of concepts, high availability, for example, minimizes downtime and cost, and it usually refers to structures within a system that basically protect against failure and keep services up and running. Fault tolerance is a little different because it usually refers to the built-in redundancy of either an application's components or a server's components, like having disks in a RAID 1 configuration, or Aurora's 6-disk copy, right? So that way components take less of a hit. Backups obviously are essential. And you might say, well, but hold on, Michael, if data is being highly available and replicated, what do I need backups for? But it's really for the corruption use case. What happens if somebody deletes something and then that gets caught up in the backup, or someone injects some malware into the system and that gets caught up in the backup? Sorry, in the replication, not the backup. But let's say it gets caught up in the replication. You need backups. You need point-in-time snapshots of your system over time to restore it. And then, of course, disaster recovery is hey, we've had a major disruption. We always talk about that in the context of a natural disaster, but let's be clear. It's probably more like a man-made disaster, like putting a comma in a configuration file. Anyway, yeah, exactly. Configuration designed to handle live malware. So this is where multi-region, for example, becomes really important. And obviously there are global services that if they go down, everything goes down. But if you're running in one region and you consider yourself to be a highly available, you're not really using AWS, to its fullest. It's funny because as a result of the outage, people are we're going to go multi-cloud with our platform. And that is totally valid if you have that use case. But if you're not in multiple regions and, obviously global outages notwithstanding, then you probably want to achieve that first before you consider going to a multiple cloud kind of setup. Again, all depends on your business case. So planning for availability zone failover, planning for regional failover, planning for instance failover. These are all the different levels of failover you want to think about. One thing I often do, and this is true whether I'm playing war games with my son, that sounds weird, but we're playing Dungeons and Dragons, or the whole family's gotten together and decided to play Call of Duty or something. It's okay, what's going to go wrong with this plan? That's usually the first question we ask. If something's going to go wrong, how is it going to go wrong? And really understanding how things are going to fail and mitigating the catastrophe of that failure, that's all part of risk mitigation. So that's all part of this kind of planning, right? So ask yourself, if things go wrong, how are they going to go wrong? Because nothing ever breaks when things are easy. Everything breaks under stress, under scale, right? So even us, we break under stress, right? You got to put people under stress if you want to fracture them, which unless you're in interrogation, please don't do that. So then we talk about these concepts of RPO versus RTO. An RPO is basically how much data can you lose? Can you lose 12 hours? Can you lose an hour? Can you lose no data? Versus how long is it going to take for you to restore this application? Whichever of these is the lowest, by the way, is going to determine the model that you use. If you can't lose any data, then you're going to use the hottest DR scenario that you can. both in terms of point-in-time recovery and data replication for high availability. If you need that service to never go down, you're going to use the hottest data available. You're going to use the hottest scenario that you can, the one that's going to have that service be fully redundant. It's going to be regionally available, globally available, right? Now, as you go on the hot scale, as far as like availability and whatnot, guess what happens? You are going to pay more money for that. Everybody comes to me and says, I want our service to never go down. Like, it's going to cost you $2 million a year. Our service can be down for 30 minutes. Awesome. So, it just really depends on what the business is willing to pay for and what the requirements are. But RPO is basically how often does the data need to be backed up? How much data can you withstand to lose? RTO, recovery time objective, is how long is it going to take for you to recover? How long can this application be down for? Whoever is the lowest, by the way, is going to drive the scenario. So, for example, if the recovery point objective is like, yeah, we just need to take a snapshot every 12 hours, but they're like, that application can never go down. What's going to happen is you're going to be like, well, okay, we're going to do the hottest one then. So whoever is the lowest, either RTO or RPO in terms of requirements, that's what's going to drive your scenario. You're going to have a really hot scenario where it's a lot of active, a lot of replication, or you're going to have a really cold scenario because both RTO and RPO can support that. So those will drive what you do from a scenario standpoint. Now, AWS has a bunch of services that support DR, things that support fault tolerance, high availability, backups, orchestration of deployment, recreation of entire environments, right? Replication of databases, replication of networking, right? Multipath routing, global acceleration. Everything that we just covered pretty much could play in this space. And whether it's a storage issue, right? You're using data sync or Snowball, or doing cross-region replication, doing snapshots with EBS volumes, or you're creating golden images with, Packer or EC2 image builder, and you've got user data in question, and you're using OpsWorks to set things up, and then you're running it in containers, or you're running it in Kubernetes, or you're using Lambda, or if you're using failover networking components like DNS for load balancing, maybe global accelerator, local load balancing using ELBs, setting up redundancy connectivity to your VPCs, or if you're just doing pure database backups and replicas like global tables in DynamoDB, or there's some, read replicas in RDS that are multi-AZ available, or infrastructure as code, or scripts. The bottom line is that almost every service is geared towards some level of like high available, supportability. So don't feel like there aren't options. That's what we designed for. Now, this is all pretty much focused on service availability. What about data? That's where backups comes in. And I think the list is actually larger now. I know it says 2021. I think this is slightly out of date. EBS volumes, RDS databases, DynamoDB tables, any of your EFS file systems. This includes Aurora clusters, by the way. I think this now includes Redshift. Anyway, AWS Backup basically allows you to set up a backup plan, and it runs on the frequency you specify, and it can put those copies wherever you need them to put them. So it allows you to centralize backups across your entire account. So, and it will give you reports, and you can track it and do responses. This is also built, in a sense for, if you throw in Storage Gateway into this, it will also back up Storage Gateway, because it's going to back up Storage Gateway to either S3, EFS, Glacier, right? EBS. So AWS Backup will allow you to grab files off of your system, whether they're tape files because you've got the Storage Gateway in what's called tape mode, or you got the Storage Gateway in file mode, and it's basically gathering data, or you've used data sync to pull data off premise into the cloud, or you've used the DMS migration service to replicate databases into the cloud, or you've used the server migration service or the data center migration service to replicate servers into the cloud. There are so many good options to make this work. Are they simple? In some cases they are, not always. It also depends on your infrastructure. You know, as far as like complexity and compliance and cost and all that, AWS backup is really great for solving those issues. This includes things like encryption, tagging, and there's no added cost for this. It's just the data that you store. Now, the way backup works is that you create a backup plan that orchestrates backup operations on a per policy basis and brings in all the other integrations that are needed. A backup vault is where you stick these backups that are executed as part of your backup plan, and you store them in the backup vault, because the vault is used to control access to your backups. You can encrypt those backups. You can set KMS as the encryption. If you want different keys, you can, set that up with customer managed keys. But otherwise, it's just going to go in the default backup vault by default. So just know that if you throw organizations in with this, with AWS backup, it will back up cross account and centralize backups across your entire account. So you throw organizations in here and all of a sudden backups starts backing up everything. So you define your timing and your roles and whatnot, so your security. Then you define the movement and the retention policy of your data in question, assign the resources to the backup plan, and you can either use ARNs or you can use tags and say, look, everything that's prod, back it up. And then you just manage and monitor your backups at that point in time. You can set expiration, encryption, retention based on time period, retention based on number. Do overlappings. First of the month backups are retained here, otherwise backup for 35 days, whatever. You can set it up the way you need to. The window, like when you want the backups to run. So backup is a fun little tool. Again, you pay for the storage you use, not the orchestration. Any questions about RTO, RPO, or just the AWS backup service, its general usage? I love that. The goal is zero downtime, but I'm worried how much this is going to cost over time. Well, that's a question to ask at the beginning of the project, not the end. But regardless, well, you can also ask it at the end, right? Because most of the time, by the way, after day zero, we spend about 4 to 10 times what we spent to get it into production to keep it in production. So something to think about. All right, so here are the 4 scenarios. These are definitely going to be on the exam. I don't know why Amazon is so hot and heavy on this on the exam, but they ask at least 1 to 2 questions in every exam that I'm at, sometimes more, about these 4 scenarios. So breathe it in. Here it comes. 1, these are not really hard, by the way. The first scenario is backup and restore. What does that mean? You back up your data to cloud. And if there's an outage, you stand up all your services and you restore from backups. So if there's like a disaster, because it's all DR scenarios, right? There's a disaster, you just stand everything back up on AWS. Hopefully you've used infrastructure as code. You restore your data, you're done. In this case, by the way, you might restore into S3, you might restore into another region. You might be in one zone, like region inside of AWS, backing up to another region. As you can imagine, this is the cheapest way to do it, but it also has the longest recovery time objective. It's going to take you a long time to do this. Even if it takes you 30 minutes to stand the systems up, it's still going to be longer. The second example is called Pilot Light. Basically what this is that you're not running the whole system over in your recovery site. You're only running a database, a secondary database. If a disaster strikes, then the database converts into primary. Servers are stood up, and hopefully they're just sitting there. They're created, but they're not running. You stand them up, you roll over DNS. Your recovery time objective is as long as it's going to take you to do 3 things. Upsize that database if necessary, boot up your app and web tiers or whatever tiers you need, and then redirect your traffic. Hopefully that can just happen really fast if there's a true outage. Very cost effective, no standby running resources, just like the backup and restore option. But You will, by the way, have to keep everything in sync. Otherwise, you're going to have discrepancies. Things aren't going to start. It's going to be problems. So this does require you to keep things in sync. I don't, honestly, as far as replicating like web server changes versus app server changes, I think that's probably actually just going to be you creating AMIs on a regular basis and using config management like Ansible, Chef, and Puppet. If you're using Lambdas and SQS, you can just use the same code that you were using before. So that just means you're going to take your CI/CD pipeline and hopefully just point it out over to AWS. The other challenge, though, Christian, is just making sure that your replication is not too laggy, and then promoting the system. So SQS and Lambda, as far as like if that was part of your original architecture on the production side, you might throw that into recovery, but I'm not sure that you would use that otherwise if it wasn't already part of the architecture. Oh, yeah. I mean, I see what you're saying. Like, honestly, it could be any infrastructure as code that you wanted to use. In other words, let's say that CloudWatch detects an outage against the system because you're putting a custom metric in, to your point, you actually could then trigger a Lambda function that then just spun the whole thing up as a result. So you could use Lambda for that. So this is relatively inexpensive with Pilot Lite, but not as cheap as backup and restore because you got a database. Oh, operational overhead. So other than just obviously monitoring backups, the operational overhead is the database system and, of course, keeping the web servers and app servers in lockstep, right? Here's an example, right? Primary failure, stand up the systems. Everything's in an auto scaling group so it can scale really well. Traffic, sorry, it's not an auto scaling group, although it could be. So it can scale pretty well. And then, basically everything stood up. I just be mindful of like running static architectures because you might need more servers on the right than you did on the left because you're doing an apples to oranges comparison of data center servers to AWS. So running these in a auto scaling group is not a bad idea, actually. All right, so past Pilot Lite. So we did backup and restore, we did Pilot Lite. Now we're moving on to the fully working low capacity standby, also sometimes referred to as a warm standby, not a hot standby. But here's the difference. The warm standby approach ensures that there's a scaled down but fully functional copy of your environment. It's in another region. It might or might not take traffic. In other words, it might be an active kind of scenario. You might put 90% of your traffic in production and 5 or 10% over on the other side. What are you doing with the other 5%? I don't know. My point being is that this could be pretty cheap because you could use the lowest, cheapest servers possible, like T3s or whatever, just to make sure the trickle of traffic shows that everything's valid. So it's fully functional, but it's not scaled to take production load. You could also, for example, leave it there to do like stage testing, for example, not performance testing, but like you're doing like user acceptance testing or some kind of staging, right? So there's two systems running, and then you can use Route 53, right, or global load balancing to determine what the weighting is. So trickle is kind of what's recommended. So this is also known as the warm standby or the fully working low capacity standby. They used to just call it warm standby. I think they wanted to get more descriptive for once. Outage, things automatically scale. Everything's good, right? All right, so we did backup and restore. Pilot Lite, which just requires database replication. Now we've done fully working low capacity standby, which is also known as a warm standby. And that actually has just low capacity systems, just doing a very simple portion of traffic. Now we're talking about multi-site active, which means you've got 2 or more sites and they're running traffic. Now here's the catch. Auto scaling is great for this because you can put 50-50 traffic, but remember, once you start shifting all your traffic load to the other site, it's going to scale up in terms of auto scaling. And then you're going to scale for load, right? You could do weighted routing for this, origin failover. I have never seen anybody do an active and leave the other one just there doing nothing. This has the least downtime of them all compared to backup and restore, pilot light, and the warm standby, but it has obviously more costs associated with it because in a sense, well, you're running 100% of the infrastructure. So I would argue actually that this isn't necessarily going to get you more cost from a server perspective because you're going to be running 50% of your traffic over here and 50% of your traffic over here. The catch is that if you have to fall back to production, which may be a standard data center, you may not have the hardware to support 100% of the traffic. If you do, then you're keeping production at 50%, which means you're kind of wasting that hardware. Yeah. Although it may be worth it because maybe you need that for your high availability. So multi-site active-active is by far the most expensive, but it does guarantee the most uptime. So that's how they scale. If you want to see these together, I think there's a chart in here. We'll get to it in a second. Here, I'm going to show you the chart first. Here's the chart. You should definitely memorize this for the exam, just pieces of it, right? Backup and restore is the coldest restore method. It's the slowest. And you're going to use backup and restore if either the RTO or the RPO is hours. If any of them is seconds, you're going to have to use the hot site multi-site standby. If any of the RTOs and RPOs are minutes, you're going to have to use the warm standby, which is the full capacity, low capacity, fully working standby. If any of the RTOs and RPOs on either side are tens of minutes, like 10 minutes, 20 minutes, whatever, you're gonna have to use pilot light. So just be aware of that. And remember, obviously multi-site active-active is the most expensive, backup and restore is the cheapest, the others fall somewhere in between. So just remember this, RTOs, RPOs of seconds, multi-site active-active, RPOs and RTOs of minutes, that's gonna be the warm standby, also known as the low capacity, fully working standby. And then tens of minutes, 10 minutes, 20 minutes, 30 minutes, that's gonna be pilot light. Anything that's gonna be hours or more is gonna be backup and restore. Any questions here? Amazon wants me to plug this just a little bit, and I have no problem doing so because quite frankly, this is a great product. This is called Cloud Endure, which I think has been renamed as of 3 weeks ago to the Data Center Migration Service. The Data Center Migration Service, by the way, is a spectacular product. Cloud Endure was a good company. I say was like somehow they've been destroyed. They haven't. They're still there. This is cool, by the way, because this actually runs an agent on each of your systems and does a block level copy to target systems that you have in AWS. It injects drivers into the operating system to make sure that it can run in AWS, even if it's coming from a VMware or a Zen or like a heat environment, right? So just know that it will do continuous replication. And then if you decide to do a cutover, it'll upsize the instances to production and stand them up, right? You can use like a target machine blueprint to define how the machines are translated. There's a machine converter in here. Cloud Endure is pretty good. If you go to docs.cloudendure.com, I don't know that the documentation system has been fully integrated into AWS yet, but soon, because they just made an announcement. But I think they're calling this now the Data Center Migration Service. Block by block copy. So pretty cool, actually. So this does basically block storage replication. All right. Knowledge check. Which DR model offers an RTO in minutes at the lowest cost? Which one of these was minutes? Now, what's funny is that I would tell you that the answer here is a warm standby. And I think the slide is wrong because if we're going by this chart, RTOs and RPOs of minutes is going to be, is it not, the warm standby, which is known as the fully working low capacity standby. So I'm just going to tell you this. They think that pilot light's the right answer. I'm going to tell you that's wrong. The answer is A. just so we're clear. It is warm standby. I don't care what this slide says. It's 100% warm standby, and I promise you it's warm standby. And this is the way I answered it when I last took the test. It just wasn't warm standby. Okay, so just ignore pilot light. The answer is A. So I already sent an email to them about this. Yeah. Which metrics define how often data must be backed up? Okay, so which two metrics will define whether or not you back up data? Like how often you back up data? So we know RPO is one. I saw that Christian put B and C, which is the data change rate. That's something people don't talk about. If your data changes once a year, what business are you in? Let's talk. If your data only changes once a day, your data changes once an hour, your data changes every few seconds, right? That will also dictate, how frequent you might need to back up. So B and C is definitely the answer here. I love data must be backed up based on available storage. No. Yeah, data volatility. That's exactly right. Which of the following are highly available resources by default? In other words, which of these operate at either a regional or a global level? Well, not 3 weeks ago. Let's not start zinging at AWS right off the bat. Not 3 weeks ago, but normally, which of these is highly available by default, right? And I see A's and B's being thrown out there. Yeah. I only say that because what the first outage was actually Route 53, wasn't it? So. NAT gateways are availability zone redundant. I'm sorry, availability zone like locked. So if the availability zone goes down, the NAT gateway goes down. So you have to run NAT gateways in multiple AZs. Direct connect is actually a physical cable, so I don't even want to talk about its lack of availability. If you want redundancy there, you need to run multiple direct connects. So through different partners, just to throw that out there. Okay, which of the following are features of AWS backup? So what are 3 things that I might have mentioned that you can actually do with AWS backups? First of all, please don't say B. I'm just going to throw that out there right now. It does not work across every service, and not B. Not yet. All right, I got encrypted backups, works across multiple services, designed for cloud native. See A, C, and D. Doesn't really do continuous data replication. That would be one of the migration services or data sync. Automated machine conversion. What service are they talking about that does automated machine conversion that I just mentioned? No. So sad. Cloud Endure. This is the one that does the machine conversion, right? It has the block by block replication. Is it weird to see a hummingbird in the fall in Atlanta? Huh, that's weird. All right. So encrypted backups works across multiple services, designed for cloud native workloads. So A, C, and D are correct. Which method will make an RDS database highly available? One of these sets of answers is about performance, and one of these sets of answers is about high availability. Okay. While it is true that running an RDS database in another region will make it like DR available, you can't run a database in another region that's synchronous, which means it won't be highly available because there's going to be a lag in the replication. So B is actually technically correct because you need to run it into another availability zone. I'm sure AWS has been working on a way to do high availability from region to region, but right now they only offer DR availability, right? So failover capability using read replicas. So it won't be highly available because there's going to be some gaps in the data transfer. I'm telling you, Christian, they are working on a device using quantum entanglement that actually communicates faster than the speed of light. I am dead serious, and they are making this work. This is real science. They took a cesium atom. I love it. You know, we live in awesome times. Anyway, run a secondary of the database in another availability zone. So you got to put it. That's what the whole multi-AZ checkbox is. If you want to make it DR available, then you can do a read replica over in another region, but that's going to be asynchronous replication. So just a reminder, and they might ask you this on the exam. When you do multi-AZ, that is synchronous replication. No data loss, because, just to say this, the primary database will not accept a write to the client until it is written to the second database. That's what synchronous replication means. It's two-step replication, two-step verification. A read replica, a database, primary database will accept a write, tell the client the write was done, and then 5 seconds later, send the transfer over to the read replica. If it crashes, that read replica will never get that update. So that doesn't happen with a synchronous replication set with multi-AZ, but it will happen with a read replica, okay? Okay. We are at the end of module 13. And technically, I guess right now the time is 3:25, so pretty close to my prediction. We've got one little piece to talk about, and it's part of the supplement, which they don't even have an ending slide deck for this, so this kind of cracks me up a little bit. Okay. Here's the funky thing. Lab 7 is in a weird place because you do the lab on Quick Labs, but the instructions are on Skill Builder. I don't have any control over this either, so just bear with me, okay? But I'm going to close out module 13.